Hello. All right, so here we go. Yesterday online, we filled in the blanks on Canvas. Did you get all the way through? All right, so we're going to maybe fill in a few gaps. Then we're going to do a couple problems from your homework, and then we're going to give you time to work on the homework. Okay, so that's the plan for today. So open up your books to section module 2.1, all about translations. The first thing in this, I think we're going to look at page 60. Yeah, I think we're going to start at 64 though. 64. On page 64, they actually talk about what a vector is. So this should go in your notes. A vector is a quantity that has both direction and magnitude. It's a quantity that has both direction. What does that mean? It means it goes east or west, up or down, left or right, north and south. Has direction. And it has magnitude. What's that mean? It has a value. So like on the problem that we just talked about, the value was 5. Okay? But in real life, sometimes that value has a different terminology. For instance, the plane's speed as it races across the ocean might have a different value. Because they use vectors to plot ships and planes as they travel. Okay, so there are some definitions. Now, one thing about a vector is it has a starting point, or what's sometimes called an initial point. An initial point. A starting point or initial point. And it also has, they use the term terminal, which is the same thing as an endpoint. So a vector has direction, a starting point, and an endpoint. So this would be the starting point, and then where the arrow is would be the endpoint. Okay. So keep in mind our warm-up. This is called vector notation. It is not, so this is called vector notation. It is different than, what's this called? Again, I'm adding stuff that's not in the book. What's that called right there? Ooh, okay, that's one thing that it gives you is a coordinate. But what's it called? Ordered pair. It is called an ordered pair. X, Y. It's always in alphabetical order. Okay, well, this is different. It's in a similar format, but because we've got these weird brackets, so to speak, it has a different meaning. Okay, and it's a vector. That's what it's the symbol for a vector notation. This is what it means. It means the change in X and the change in Y. The change in X and the change in Y. Okay? If you think of the warm-up, this should make sense. Isn't that the vector notation for the warm-up? That when you guys told me it went up 4 and over 3, right? Okay, and so All right, in your own words, in your, not mine. You can steal my words if you want. I don't mind. James, what does this mean? In your own words. You can steal my words if you want. Which way over? Do we go to the right when it's negative? Go to the left. You're really close. That's right. He said down 2, and then he said over 3. When I asked which way, you got to know because it's negative, Michaela, which way do you go? That's right. Left or down. That makes sense? It's that simple. Not harder than that. Okay? All right. Good. Let's turn the page over and go to the top of page 66. There's a problem up there. Your turn, number 4. Let's take a look. Your turn, number 4. Now, you probably did this yesterday in class, but I'm going to fill in hopefully a couple questions or blanks maybe as you were looking at it. Okay, so I'm not going to have quite the pretty grid that they have in the book, but I am going to make a picture here. All right, Maddie, help me out here. Does the vector look like this? That's the vector? Everyone agree that's the vector? Okay, well, let me ask them more specifically. Mason, which end is the starting point? How would you describe it? Would it be this end or that end? No. Good guess, though. I mean, you had a 50-50 shot at it. This is the starting point. And where the arrow goes, that's the terminal point. That's the end point. Okay? So if this is the starting point, you're going to have to count on your grid in the book. How far over does it go, Colby? Positive 5? Attaboy. Negative 5. Thank you. Don't always listen to Bo. How many units down does it go, Bo? Thank you. Everyone agree with that? So the vector notation, they don't ask for this, by the way. This is free. This is extra. The vector notation in this one would be negative 5, negative 2. Rainy, got it? That makes sense? Okay, so if this is my starting point, and this is my ending point, I kind of make a right triangle, and I count, all right, how far over does that vector go? And I just count the boxes. Okay? And then I count the boxes going down. And that's where they get to 5 and 2. All right? So then, now the actual question is, move the triangle. Translate the triangle. So, again, I'm going to do it very roughly. You guys can do it exactly in the grid. I take A and I go over 5 and I go down 2. And there's A prime. I take B and I go over 5 and down 2 and there's B prime. And I take C and I go over 5 down 2 and I have a new A prime, B prime, and C prime. Okay? So that's what you have to do in that grid. So you're just counting over from each point. 1, 2, 3, 4, 5, and then 1, 2. That's all you're doing. And then you're plotting that point. That would be A prime. Okay? So you don't have to do ordered pairs or anything like that. You just move it over 5. and then down 2. How does that make sense? Laney, does that make sense? All right. So go ahead, and if you haven't already, go ahead and plot that new triangle. I'm going to shade mine in just for fun. There's my new triangle. Nicholas, you all right?
Yeah.
Okay, good. Colby, piece of cake? Okay. Move along. Let's go over to the next page, 67. Let's take a look at number 6. You got any? All right, let's go to number 6. Your turn, number 6. All right, Lily, give me the coordinates.
2, -1.
Hold on. I gotta make sure I'm on the screen. P is 2, -1.
And then Q is 2, -3.
2, -3.
And then R is 4, -3.
R is 4, -3. Those are given, right? Okay, what vector, Maddie, are we using? Given in the instructions. Good. All right. Chase, what's that mean, -4, 1? That's right. To the left 4 and up 1. Very good. All right, so there's 2 ways to do this. They actually give us a grid to do it. So let's do that first, and then we're going to take you mathematically. That you could just do it mathematically. All right, so let's do the grid first. All right, so let's see. P is 2, -1. 1, 2, -1. There's P. Q is 2, -3. 2, 3. There's Q. And R is 4, 3, 4, -3. Okay, so we plotted that point. Now we have to apply the vector. Okay? That means that we're going to go, as Chase said, we're going to go -4 units on the X. So the whole triangle, look at my pen, the whole triangle is going -4 units this way. And then the +1 means we're going to move it up 1 unit. Okay? I'm going to go point by point. All right, let's do P first. So P is here. I'm going to go 1, 2, 3, 4. And how far up am I going? 1. So there's my endpoint for P prime. We're okay so far? Okay. I'm going to do Q now. -4, 1, -2, -3, -4. And I'm going to go up 1. So there's my point for Q prime. Lily, you all right? All right, now let's do R. We're going to go 1, 2, 3, 4. We're going to go up 1. 1, 2, 3, 4. R prime. Mine's not near as good as yours in the book. Now I'm going to connect these. You should see that these are parallel lines. Those look like parallel lines? Not bad. They should be parallel lines in yours, though, because the grid's more accurate. Does everyone see the parallel lines? I mean, they never touch. Okay. So, well, that's really all they wanted. They just wanted you to plot triangle. Let's see. Draw the preimage and the image of each triangle. That's all they really wanted. We're going to do a little extra. All right, so could we do this mathematically? Sure. P prime. Bo, what's 2 plus -4? Got it? Negative 2. There you go. All right, and then what's negative 1 plus 1? Okay, so that means P prime coordinate should be 2, 0, right? Is it?
Yes.
Pretty slick. Nicholas, you see that?
Yes.
All right, Colby, you're up. Q prime. What is 2 plus negative 4?
-2.
And then what is negative 3 plus 1?
-2.
That should be the coordinate of Q. Let's see. Negative 2, negative 2. It is. See how I'm doing it mathematically as well as the graph? Okay. And then Elise, R prime. What's 4 plus negative 4? And negative 3 plus 1? Should be 0, negative 2, and it is. Got it? Good. So this is the coordinate of our new triangle. I didn't ask for that, but I wanted you to see, so it's kind of a connection. All right? All right, good. Let's move on. Let's do a couple problems from the homework. First one we're going to do is, let's see. Let's go to number 9. It's on page 69. I know I haven't given you the numbers for the homework yet. I will at the end. Just turn in your book to page 69 and problem number 9, and let's look and see what it has. Okay, it looks to me like it's got a grid. We have G and an H. Mason, back to you. Tough question. Which one's the initial point? Yep. Oh boy. Good job. It wasn't a tough question. It's just the same one I asked you before. And I wanted to make sure you picked up on it. So A then, or H, is then called the terminal point or the end point. Okay, so how many across, Carter? How many across is it? 5 units. How many down is it? So to me, the vector, pretty simple. -5, -2. Everyone see how we found that? Lily? Hope? Maddie, you okay with that? All right, so they don't ask for this, Maddie. What if I started at H and I went to G? What would be my vector then? Very good. Right. Very good. Good job, Maddie. Huh? No, the direction matters. In fact, you can see that it just gives you the opposite. Negative. Let's go over to, let's do a more difficult one. Let's go to number 13. All right, I'm not going to do it exactly because you've got the grid there. I'm just going to make a somewhat of a picture of the trapezoid. Yeah, it's not very good, but all right, so this is A and this is A prime. That's all I want you to look at for now. Okay? A to A prime. Everyone seeing A to A prime? Kylie. A to A prime. Think of that as a vector. If I had a straight edge, and I connected A to A prime, just like the vector that we were talking about before. You see A to A prime? Got it? How far over to the right? How far over to the right does it go? Kylie. 2. Kylie, how far down? So if I'm thinking from A down to A prime, how far down does it go? 5? You guys verify? So what would that value be then? So 2, I'm going down 5. What's the value? There you go. Landon, does that make sense? Yeah. That's the answer for number 13. See how easy that is? Huh? No, I said a more difficult one. I didn't say the most difficult. Okay, but you get the idea of vectors and how they are connected to translations, because that's the lesson. Okay, let me write down the assignment. Is page, the starting page number 69. Then we do 1 through 3, 5 through 9, 12 through 14, and 18 through 20. Page 69, 1 through 3, 5 through 9. We've already done 9 and 13. So we already did 2 of them for you. 7, what is that? 10, 13 problems. Woo. You should get done. We had people get done last period. So, okay. All right, let me stop recording, and I'm going to try and get this uploaded for you virtual students.